Hey, my name is Alexis, and welcome to my molecular portfolio for Chem 305. Today we will be discussing Allegra. So, you may have seen Allegra in commercials of a lady probably sneezing, and then later seen going outdoors and just enjoying her day. So there are other common brand names besides Allegra that treat the same symptoms, which is allergies, Allerfex, Walfex allergy, children's Walfex, children's Allegra allergy. The generic name for this drug is fexofenadine hydrochloride, which is the active ingredient in the drug. The chemical name for this drug is 2-4-1-4-4-hydroxy-4-4-hydroxy diphenyl in parentheses methyl bracket piperidine -1 -YL butylphenyl bracket -2 methyl propanoic acid semicolon hypochloride. Now try to repeat that 5 times fast. What is this drug used for? So this drug is used to help treat symptoms of hay fever and skin hives. Hay fever is just a very fancy way of saying seasonal allergies. So the symptoms of hay fever and skin hives might include itchy skin, crying eyes, runny nose, sneezing, and itching. On to bigger and better things. When should you stop taking this drug or just straight up not take this drug? So contraindications is just basically when you should not interact with this drug at all. So if you have an allergic reaction, let's say you are experiencing symptoms of fever, chills, body aches, cough, and other flu-like symptoms similar to the coronavirus, or like some like to say, you should definitely stop taking this drug. You should also not take this drug with any fruit juices, as fruit juices actually decrease your ability to absorb the drug by 60%, so you're only getting about 40% of the benefit that this drug has to offer you. And if you do drink juice, they say you have to wait 4 hours before you could even take this drug, or you should take this drug so you can get the benefits of it. You should also not take this drug with an antacid, as antacids also make it difficult for your body to absorb it. And like many medications, don't drink alcohol because you don't know the side effects and something serious might go down. So that is a no-no. Common flu-like symptoms or common symptoms that you may experience as side effects is nausea. Maybe you have an upset stomach or diarrhea, muscle pain, drowsiness, headache, or you might have menstrual cramps if you are a female. You should consult your doctor if you are 65 years or older, are pregnant or breastfeeding, or you have kidney disease. So definitely talk to your doctor. Alright, just like chemistry, there are a lot of reactions that can occur if you mix things together. So with Allegra, you should be aware that you shouldn't mix it with opioid medications, sleeping pills, muscle relaxers, or anxiety medications, as that may increase drowsiness or sleepiness. You should consult your doctor if you are taking an antibiotic for an antibacterial infection, because that may have significant interactions as well. They may vary depending on the medication. So always do your research. For the interesting drug fact of the day, Allegra often speaks confidently about how their drug does not cause drowsiness. However, when most people take Allegra, they often feel very sleepy. So what does Allegra look like? Well, its molecule, fexofenadine, will look a little something like this. So the structure I am drawing shows the arrangement of bonds between atoms. So this hexagon structure I have up here is called an aromatic ring. It consists of 6 carbons with alternating single and double bonds. Coming off the point of the hexagon is a carbon in the middle of what looks like a plus sign. To the left, I am adding an oxygen with a single bond of hydrogen. Now I'm going to add another aromatic ring to the right, and coming off that last point of the what looks like a plus sign is another hexagon with 5 carbons and a nitrogen at the point of it. Coming off that nitrogen, I am going to draw a zigzag line representing carbons at each point. So there's a total of 1, 2, 3, 4 carbons. Coming off that 4th carbon, I am going to add an oxygen. And then coming off that oxygen is a hydrogen. So I'll put that on there. And I'm going to put another aromatic ring. And coming off that final ring, I am going to add a carbon, which is going to come off that point at the end. And coming off that carbon is going to be double bonded with oxygen, and then single bonded to another oxygen, and then one more hydrogen. One thing that I did not list in this video or include due to the software I was using is there should be 2 lone pairs on each oxygen and 1 lone pair on the nitrogen. And this is what fexophenadine looks like, or aka Allegra. So this is the expanded structure, which is similar to the skeletal structure that we did in the previous slide. The only thing different is now you can see the carbons and then the hydrogens coming off the carbons, as well as the lone pairs of electrons. Alright, so the VSEPR theory is just basically the geometric structure, which is in a 3D form. So you will see my molecule on the left, and then on the bottom right-hand corner is my molecule in 3D. So I have highlighted all the central atoms in my molecule to the left to represent certain structures. So we have the bent, the trigonal planar, the tetrahedral, and the pyramidal. The bent is essentially just 2 surrounding atoms with 2 lone pairs. The trigonal planar is 3 surrounding atoms. The tetrahedral is 4 surrounding atoms. And then the trigonal pyramidal is 3 surrounding atoms with 1 lone pair, which is just my nitrogen all by himself. Molecular formula and molar mass calculations. So if I want to know how much does this molecule weigh, and this molecule is fexophenadine, that is its drug name. So how would I know how much it weighs? Well, I can look at its molecular formula, which is to the right of this screen, which is C subscript 32, H subscript 39, NO4. And how do I know how much each atom weighs? Well, I can look at my handy dandy periodic table, which you should look at periodically if you want to know the molar mass. So I look at carbon, and I can see that it weighs 12.011 grams per carbon. And if I want to know the mass of this whole molecule, I will need to account for each carbon that makes up the molecule, as well as the hydrogen, the nitrogen, and the oxygen. So I will take the mass of one carbon and I'll multiply it by how many are in this molecule, which is 32, and I'll do the same, so on and so forth for the following elements that are in this molecule. Then I will add up their totals, and once I add them up, which is my calculation is here on the right, I will know that fexophenadine weighs 501.67 grams. hydrogen bonding with water. So this is just an example molecule, and I'm just going to briefly go over what water likes to bond with. So the hydrogens on water like to bond with either an oxygen, nitrogen, or fluorine on another molecule. So the molecule we have here, you can see all the hydrogens loving and bonding to those following elements, but they do have to have a lone pair available. Any hydrogens that are on this molecule like to bond with the oxygen on water. So let's take a look at what my molecule looks like. So here we have Allegra bonding with water. Here's my molecule. There are 3 H bond donors, so there are 3 hydrogens on my molecule that are attracted to the oxygen on water. And then I have 5 H bond acceptors. So there's the oxygens with their lone pairs that are attracting the hydrogens on the water. Polarity and solubility prediction. Is fexofenadine soluble in water based on its polarity? Well, based on the previous slide, we can tell that fexofenadine does attract water molecules. So I would say there is some solubility there. If we were to just look and think about lectures that we have learned how like dissolves in like, we might refer to the intermolecular forces. So looking at the intermolecular forces, water and Allegra are very similar in that sense. But when I look at the molecules themselves, looking at their skeletal structures, I do notice that fexofenadine has more CH bonds. Even though it does have polar sites where there's dipole moments occurring on the oxygens, nitrogens, it's mainly composed of CH bonds, which are considered nonpolar. Therefore, I would say fexofenadine is slightly soluble in water. Referring to PubChem, it states the same thing. It believes that this drug is slightly soluble in water, but it says it's freely soluble in methanol and ethanol. When I looked at those structures, they are very similar to fexofenadine in that they have the CH bonds, and they do have an oxygen attached to a carbon or an OH attached to a carbon, which is similar to this structure, whereas water doesn't have that. It doesn't have those nonpolar bonds attached to this molecule. So it is slightly soluble in water. Solution calculation. So how would I go about prepping a solution with my drug? So let's say I want to create 50.0 milliliters of a solution, and I have a molarity of 2.30 times 10 to the negative 2 molarity of fexofenadine, which is my drug Allegra. I would look at what does molarity mean. It means moles over liters. If I play around with that equation, I could find moles. So moles equals molarity times liters. If I input that in and make sure to convert milliliters to liters to be equivalents to molarity, I can find the number of moles. But I can't count each atom out of my drug, so I need to find out how many grams. Well, we can refer back to my previous slide where we found the molar mass of my drug, and you input that in there to find the grams. So this will help you figure out how much to put in there if you wanted a certain concentration of a solution. Now, if I wanted to calculate how many milligrams of a drug are contained in a 2 milliliters of 3.0% weight over volume solution of fexofenadine, well, I would take the concentration of weight over volume percent, mix around that equation so I could find the mass of the solute. I just input the information and convert grams to milligrams to find how many milligrams of the drug are contained within that solution. We did it. We got through it. Thank you guys for watching. And I know finals around the corner, so I just want to leave you with one study tip. Don't drink water while studying because chemistry says concentration decreases when adding water.